All right, everybody, welcome back. We're going to be doing a deep dive today about debugging.
Ooh, debugging.
I know. It's not the most glamorous topic.
No.
But you know what it's like, the foundation
Yeah.
of good coding.
It really is.
Right. If you can't debug your code, you're not going anywhere.
Absolutely. And you know, the thing that's so funny about debugging is that I think a lot of people think it's something you just kind of pick up along the way.
Right, like it's an afterthought.
Yeah. But actually, you know, we were looking at this amazing online guide,
Okay.
and it was talking about how much time developers actually spend debugging.
Oh, really?
A lot of time.
Yeah, so it's something we should really be focusing on and honing as a skill.
Like a craft.
Yeah.
So this guide that you're talking about, is this something that's for beginners or is it for everybody?
Honestly, I think there's something in there for everybody because, it covers all these different types of bugs from the really easy ones like syntax errors.
Oh, yeah. All the way to super complex things like logical errors and semantic errors.
Wait, okay, so I know a syntax error is when you miss a semicolon or forget a parenthesis or something.
Right. It's like the grammar of coding.
Right.
If you mess that up, the computer's not going to understand what you're trying to say.
Totally.
Yeah.
Yeah, but what's the difference between a logical error and a semantic error? Those sound kind of similar.
Yeah, they can be tricky.
Yeah.
Okay, so imagine this. You're baking a cake.
Okay, I love cake.
Who doesn't? You follow the recipe perfectly, you measure everything out carefully, but then when you taste it, it's completely wrong. Maybe you accidentally put in salt instead of sugar. That's kind of like a logical error. The code itself runs without crashing, but the outcome is not what you intended.
Oh, so the logic is messed up.
Exactly.
Okay, I kind of get that now. But then what's a semantic error?
A semantic error is when your code works perfectly fine, technically, but it's not doing what you meant it to do. So, let's say you wrote a program to sort a list of names alphabetically,
Okay.
but instead it sorts them by length.
So it's still sorting, but not in the way you wanted.
Right. So it's technically correct, but not really useful.
Wow, okay, those are way more sneaky than a syntax error.
Right.
Okay, so we've got this whole bug zoo
Yes.
that we got to deal with. So what are some strategies for actually finding and fixing these things?
Well, the guide talks about a bunch of different techniques, but honestly, one of the most basic and surprisingly effective ones is something called print debugging.
Print debugging.
Yeah.
What is that like, printing out your code and staring at it?
Not quite, but kind of. Basically, you add these little print statements
Okay.
at different points in your code, and then you run it.
Okay.
And those print statements will show you the values of your variables.
You can see what's happening step by step.
Exactly. It's like leaving a trail of breadcrumbs to follow.
Okay, that makes sense. But is that the only way to debug? What about fancy tools and stuff?
Yeah. So once you get a little more comfortable, there are these things called IDE debuggers.
Debuggers.
Yeah. And honestly, they're super powerful. Imagine you could actually pause your code.
Pause it.
Yeah, at any point, and then look around
What way?
and see what all the variables are doing and even change them on the fly.
So it's you can step into the code and see how it's working.
It's like having X-ray vision into your program.
That's incredible. So much better than just staring at print statements.
Way more powerful.
Okay, but what about those times when you're super stuck and you just can't figure out what's wrong? You've tried everything.
You've tried print debugging, you've tried the IDE debugger, and you're still pulling your hair out.
Yeah, exactly.
Okay, well, have you ever heard of rubber duck debugging?
Rubber duck debugging.
Yeah.
What is that like? Taking your code to the bathtub.
Okay, not exactly.
Okay.
But it does involve a rubber duck or really any inanimate object.
Like a stuffed animal or something.
Exactly. The idea is you explain your code line by line to this object.
To the rubber duck.
Yes, as if it could understand you.
So I'm teaching my rubber duck how to code.
You got it. And it might sound silly.
It does sound a little silly.
But trust me, it works. Because when you force yourself to explain your code out loud, you often end up spotting the error yourself.
So it's you're talking through the problem, and that helps you think more clearly.
Exactly. And sometimes just hearing yourself say it out loud makes you realize, wait a minute, that doesn't make any sense.
Wow. Okay, I might have to try that next time I'm stuck. What other tricks do you have up your sleeve?
Well, there's a classic problem-solving strategy that also applies to debugging. Divide and conquer.
Divide and conquer. Isn't that a military tactic or something?
It is, but it's also a great way to approach complex problems. Basically, you break down your code into smaller chunks,
Okay.
and then you test each chunk individually.
So if you find a bug, you know it's got to be in that specific chunk.
Exactly. It's like eliminating suspects in a detective story.
Makes sense. Okay, last question, log file analysis. I've heard that term thrown around, but I'm not really sure what it is.
Yeah, that's a little more advanced. It's super useful when you're working on like big applications, especially those running on servers. Think of it this way. Your code is a city,
Okay, a city?
and the log files are like the security cameras.
Oh.
They're recording everything that happens.
So you can go back and see like what led up to a problem.
Exactly. It's like having a detailed history of your program's execution.
Wow, that sounds really powerful. I guess that's why the pros use it so much.
It's essential when you're dealing with like really complex systems.
Okay, this is all really fascinating, but I think we need to take a break and let all this information sink in
Agreed. We've covered a lot of ground already.
in just the first part of our deep dive.
I know, but don't worry, we'll be back with part 2, where we'll delve even deeper into the art of debugging.
We'll be back soon.
We'll see you then. Welcome back to our debugging deep dive.
All right, so we talked about all sorts of bugs
Yeah.
and some basic debugging strategies,
Print debugging.
rubber duck debugging.
Yeah.
But I think we need to go a little deeper.
Okay, yeah, let's level up our debugging game.
So what happens when we hit those really tough bugs? Those ones that just make you want to like throw your computer out the window?
Yeah, the ones that keep you up at night.
Exactly.
Way
What do we
better.
do then?
Well, the first thing is to not panic.
Easier said than done sometimes.
I know.
Yeah.
But seriously, freaking out isn't going to help.
Right.
It's like, okay, take a deep breath.
Okay, deep breaths.
And remember that even the best programmers get stuck sometimes.
So I'm not a total failure if I can't figure out this bug.
No, everyone hits these roadblocks.
Okay, that makes me feel a little better.
Good. Because once you accept that debugging is part of the process,
Right.
you can start approaching it more strategically.
So it's like a puzzle to solve.
Exactly. And every puzzle has a solution, even if
Okay.
it takes a while to find it.
Okay, so what's the first step in solving this debugging puzzle?
Well, you got to make sure you really understand the problem.
Okay, so don't just jump into trying to fix it.
Right. Like, what exactly is going wrong? When does it happen? Can you reproduce it consistently?
So it's like gathering clues, like a detective.
Yes. The more information you have, the easier it will be to pinpoint the root cause.
Makes sense.
Yeah.
So once we have all our clues, what's next?
Then it's time to start testing our theories. Like, okay, what do we think might be causing this bug? And how can we test that?
So this is where our debugging tools come in handy.
Exactly. Whether it's print statements, the debugger, or even just stepping through the code manually.
It's all about getting a better understanding of what the code is actually doing.
Yes. And remember, sometimes the simplest solutions are the best.
So don't overthink it.
Exactly. Sometimes just taking a step back and looking at the code from a fresh perspective can help you spot something you missed before.
I've definitely had that happen. Like I'll stare at the code for hours, and then I'll take a break, come back, and suddenly the solution is obvious.
Right. It's amazing how that works.
It's like magic. But sometimes even with all the tools and strategies, we still get stuck.
Yeah, it happens.
So what do we do when we hit those really tough roadblocks?
Well, sometimes you need a fresh perspective.
You mean like ask someone for help?
Exactly. Talk to a colleague, a mentor, or even just someone who's good at problem solving.
So even if they don't know how to code, they might be able to help just by listening and asking questions.
Sometimes just explaining the problem out loud can help you see it in a new light.
It's like rubber duck debugging,
Yeah.
but with a real person.
Yeah. And don't be afraid to use online resources too, like Stack Overflow is a lifesaver.
Oh yeah, Stack Overflow is amazing. So many times I've found the answer to my problem there.
It's like a collective brain of programmers from all over the world.
Okay, so we've talked about asking for help and using online resources.
Yep.
But what about those times when you just can't seem to find the answer anywhere?
Well, sometimes you just got to get creative.
Creative. How do you get creative with debugging?
Well, sometimes you got to try things that you wouldn't normally think of. Like, what if you just commented out this entire section of code?
Just to see what happens.
Yeah. Or what if you tried running the code with a completely different set of inputs?
So it's about experimenting and seeing what happens.
Exactly. Sometimes those unexpected results can give you the clues you need to solve the puzzle.
Okay, I'm starting to see the fun in debugging now.
Right. It's like a game.
A very challenging game,
Yeah.
but a game nonetheless.
And the more you play, the better you get at it.
So true. Okay, so we've covered a lot of ground in this part of our deep dive.
Yeah, we have.
We've talked about the importance of staying calm,
Yes.
breaking down the problem,
Gathering clues.
testing our theories,
And asking for help when we need it.
all essential skills for any debugger.
Absolutely.
Welcome back to our deep dive all about debugging.
So we've talked about different types of bugs. We've
Yeah.
talked about techniques,
Yeah.
tools. We even talked about like the whole detective analogy.
Yeah.
But there's one thing we haven't really touched on,
What's that?
and that's the mental game of debugging.
Okay, the mental game.
Yeah, because let's be real, debugging can be frustrating.
Super frustrating.
Like, sometimes it feels like you're just banging your head against a wall.
Oh, yeah, totally. Like you're going in circles and you're never going to find the answer.
Exactly. And that can really mess with your motivation.
For sure, and your confidence.
Totally. So it's like super important to develop a healthy mindset around debugging.
So how do we do that? Like, how do we not let those bugs get to us?
Well, first of all, remember that everyone makes mistakes.
Even you.
Even me. Even the most experienced programmers.
Okay, so it's not just me who feels like an idiot sometimes.
No, not at all. It's just part of the process.
So, like, bugs are normal?
Totally normal. In fact, I'd say they're inevitable.
Okay, well, that makes me feel a little bit better.
Good. Because once you accept that bugs are going to happen, you can start to see them as opportunities to learn.
Opportunities.
Yeah, like every time you fix the bug, you're learning something new about your code, about the language, about problem solving.
So it's like a challenge to overcome.
Exactly. And it's way more satisfying to solve a tough bug than to write perfect code on the first try.
I guess that's true.
Right. So the next time you encounter a bug,
Uh-huh.
don't get discouraged.
Okay.
Take a deep breath
Deep breaths.
and approach it as a learning opportunity.
I like that, yeah. But still, sometimes it's hard to stay positive when you're stuck on a bug for like hours.
Oh, yeah, I know the feeling. But here's a tip that really helps me.
Okay, I'm all ears.
Take breaks.
Breaks.
Yeah, like if you've been staring at the same code for an hour and you're getting nowhere, just step away for a bit.
But get up and walk around.
Yeah, or grab a coffee, chat with a coworker, do something completely unrelated to coding.
Okay, so like clear your head.
Exactly. And you'll be surprised how often you come back to the problem with a fresh perspective and suddenly the solution is obvious.
Oh, I've totally had that happen.
Yeah.
It's like magic. But sometimes even breaks don't help and I'm still stuck.
Okay, well, in those cases, don't be afraid to ask for help.
Ask for help. Like admit defeat.
No, not at all. It's just being smart about using your resources.
Okay, so who should I ask for help?
Well, it could be a colleague, mentor, or even someone in the online community. There are so many great forums and websites where you can connect with other developers and get advice.
Oh, yeah, like Stack Overflow.
Exactly. Don't underestimate the power of the community.
Okay, that's a good point. So we've talked about taking breaks and asking for help, but what else can we do to improve our debugging skills?
Well, like with any skill, practice makes perfect.
So the more bugs we fix,
Yeah.
the better we get at it.
Exactly. And there are tons of resources out there to help you practice, like online coding challenges
Oh, yeah.
and open source projects where you can contribute and work on real-world code bases.
Okay, so debugging is like a muscle. The more you use it, the stronger it gets.
I love that analogy. And remember, debugging isn't just about fixing bugs, it's about becoming a better programmer.
Okay, I'm starting to see that now.
Right. It's about understanding how code works, how to break down complex problems, and how to think logically.
And it's about perseverance.
Yes. Never give up on a bug.
So true. Well, I think we've covered just about everything there is to know about debugging. At least for now.
Yeah, this has been a really great deep dive. I feel like I've learned so much.
Me too. And I hope our listeners have too.
I'm sure they have. So to wrap things up,
Okay.
remember that debugging is a skill that takes time and practice to develop.
Yes.
But it's a skill that's absolutely essential for any programmer who wants to create great software.
Absolutely. So embrace the challenge, stay curious, and never stop learning.
And remember, every bug you squash is a victory.
That's right. We'll see you next time for another deep dive into the worlds of software development.
Until then, happy debugging, everyone.